Okay, we are looking at exponential functions. In the last video, we were looking at mostly parent functions of exponential functions. Now we're going to look at transformations. All right, so the equation that we're going to use, f of x equals a times b raised to the x minus h plus k. This is just your general form, okay? A, b, h, and k, these are still just going to be numbers. X and f of x is your y, those will still be the variables. So it's exponential because your x is your exponent, and that what makes it an exponential function. All right, so let's look at what some of these things do. H is the horizontal shift, so whatever the number h is here is going to shift you left or right. If it's plus h, it's going to shift you to the left. And if it's minus, it's going to shift you to the right. Okay, so refer to these notes when you're graphing to see if it makes sense what's really happening. K is the vertical shift. That means it's going to shift you up and down. Plus shifts you up, minus shifts you down. If A is negative, the function is a reflection. So if the number in the front of the equation here is negative, it's going to reflect across the x-axis. If the absolute value of A is greater than 1, that represents a vertical stretch. If the absolute value of A is between 0 and 1, that represents a vertical compression. Make sure you have these notes and refer to them when you want to, but we're now going to start graphing. Okay, when graphing, we need to know what is happening, what kind of transformation we have. So this says identify the parent function and describe the transformations. All right, for number 1, we've got f of x equals 3 to the x plus 5. So A part, identify the parent function. F of x equals 3 to the x power. That's our parent function, the most basic part of the function. Plus 5, that's going to be a vertical shift. So it's going to move us up 5. Number 2, our parent function is 1/4 to the x. So f of x equals 1/4 to the x power. And for this one, we have a 2 out front, which is a vertical stretch. Times 2. And we have a 1, so this negative 1 is actually going to move us right 1 unit. All right, for number 3, our parent function is 4/3 x, so f of x equals 4/3 to the x power. And because this is negative, that means we have a reflection over x. And again, you can refer to your notes right above to see where I'm getting this. So reflection over x because it's negative. And then this plus 2 actually moves you left So that moves us left 2. And the last thing we have is this positive 7, and that moves us up 7. All right, last one, the parent function, 1/2 is our a, so 5 to the x power, so f of x. Our parent function is f of x equals 5 to the x power. And then we have a compression. So this is a vertical compression. F1/2. And then this negative 4 is going to move us right 4 and down 2. Okay, so each one of these numbers is going to be something that makes the transformation, it makes the graph shift in a direction. So now let's look and see how that works visually. All right, so now we're going to graph each function and identify its key characteristics. So you can see I've already made a table here. So x and y, and this is for the parent function, f of x equals 2x. If you remember, we graphed this in the last video talking about the parent functions. So this is f of x equals 2 to the x and then plus 5. So in the notes we just talked about the plus 5. That is a horizontal shift, and it's going to shift you left 5. So that means our x value is going to go negative or left 5. So if we take negative 2 and go left 5, that's going to put us at negative 7. If we go left 5 from negative 1, it's negative 6. Left 5. Left 1 minus 5 would be negative 4, and 2, move it left 5, that's going to give you negative 3. All right, so we're not changing the y values in this problem. There's no vertical shift, there's only a horizontal shift. So we're going to change the x's, and the y's are going to be the same from the parent function. So you can just bring those over. And again, if you're not sure, if you don't remember where these x's came from, just watch the other video, because all we had to do was take the negative 2 and plug it into the parent function. 2 raised to the negative 2 is the same as 1 over 2 squared. 1 over 2 squared is 1/4, and that becomes 0.25. So these numbers just came by plugging the x's into the parent function to get these. And then this table again, we're shifting the x's left 5, because that's our transformation, and then everything else stays the same. So to put these on the graph, we're going to go over negative 7. 1, 2, 3, 4, 5, 6, 7. All right, once you have your points on, you are going to sketch your exponential function graph again. And you can see, like in the last video, it's going to have the same basic shape. It's just going to be shifted to the left 5. All right, so we can look at this and we can see that the isotope here, it's still the same. So it's still going to be at y equals 0. And we can see that the domain is still going left and right with arrows. So that means it's going to continue on. The range, again, is still above 0. So we can say y greater than 0. The end behavior, okay, as x goes positive, or to the right, this is going towards infinity. And as x goes negative, or it goes to the left, it's approaching 0. All right, now one thing that has changed is the y-intercept. So the y-intercept is, we're not seeing that here, it's not crossing the y yet, but you can plug in 0 to find the y-intercept. So if I take 2 to the x plus 5, and I simply plug in 0 here, I'm going to do 2, 0 plus 5, which is 2 to the 5th power. And the 5th power, 2 to the 5th power is 32. So if my x is 0, my y is 32, and that's my y-intercept. Okay, we're going to look at another example. If you look at the parent function again, f of x equals 1/3 to the x power. That's the table that I have right here. Again, I just plugged in my x's and use my properties of exponents to simplify. For f of x equals 1/3 x minus 2, that means it's going to be a vertical shift down. That means my y values are going to change this time. So I'm going to keep my x's, -2, -1, 0, 1, and 2. All right, this time each x is going to shift down 2. So from 9, I go down 2, I'm at 7. From 3, I go down 2, I'm at 1. My y here is 1. I'm going to go down 2, puts me at -1. And then if I'm at 0.3 and I go down 2, I'm going to be about -1.7, 1.6 repeating. This is repeating, so it's a little bit more than that. And then this one's repeating as well. But if I go down 2 from here, it's going to be 1.9, or since that's repeating, about 1.8, so -1.8. And then I'm going to graph my points. This is the function I want to graph, so I'm going to use this table. So -2 and 7. -1, 1. 0, -1. And 1, -1.6, 1.7. Again, there's no way to get exact on these. You just got to get close. And 2 and -1.8. So you can see that's where it's starting to level out. Not really level out, still decreasing, but it's approaching that line. It's not going to go below that line, so I've got to be careful how I draw it. And it's going to sketch something like that. Much easier with a pencil and graph paper than on the computer, but hopefully you can see where the points need to be. All right, your domain again is going left and right forever, so we're going to call that all reals. Our range, this time our range, if you can see, our range is going to be all numbers above where my graph is. So that's going to be this line right here. So that's going to be y greater than -2. And then my x is approaching positive infinity. My y is approaching -2. And as x goes to negative infinity, it is going up. So it's going to positive. All right, here you can see that the y-intercept is at 0, -1. And the isotope this time has moved down, so it is at y equals -2. And remember this, a new definition. This is the line that the graph is approaching or going towards. It's not going to get there, but it's going towards that line.